Hello, people. We are on the next section of this chapter. We are doing series circuits. Okay, so I hope you enjoy the dad joke. It's a good one. And let's start this up. Okay, I didn't want to put a picture here. I'm just going to start explaining it. Okay, first thing is you got to have your formulas from the last 8.1. Okay, so let's remind ourselves. V equals IR, that's voltage is equal to current times resistance, right? Current is measured in amps, which we write an A for. Resistance is measured in ohms, which we use a omega for. And voltage is measured in volts, which we use a V for, right? Next thing you also got to remember is power, which is I times V, yeah? And so power is measured in watts. I is measured in amps, just like we said, and voltage is measured in V. Yeah? Look, it's a wave. Okay, so going forward, I'm going to show you what a series circuit is. Now, I kind of already showed you a series circuit last time. Okay, it's to have a circuit, you need some sort of a power source. Yeah, in this case, let's say you have a battery. Now, on like with physicists, we don't want to draw a battery every time we're trying to resemble that. We want something that's easier, something that's quicker. So for us, for our uses, we just use a small line and a big line, and that means battery. Okay, and then like a car battery has 12 volts, right? So next to that battery, we'll say how many volts it has. 12 volts. Now for a circuit, remember a circuit has to complete all the way around to be a closed circuit, and that's how we get power, right? So we're going to have that wire connecting from one terminal to the other terminal. Okay, and there's my battery connected to a circuit. Now, the other thing that we need to write in here, now we don't have, so you now know the basically the symbol for voltage. It's the battery, which is like that. Yeah, on a circuit, that's how we resemble voltage. I sometimes they'll put an amp meter in here to tell you what the amps is. I'm not going to do that to any of you, but if you want to see how it looks like, it's just a circle with an A in it. And that means amp meter. Okay, but that's for future uses. I'm not going to do that. Okay, to use a symbol for resistance, we do a little squiggly line. Okay, and that's just like this. Okay, and that means resistance. And next to it, they'll put how much resistance, like the wire or that portion of something. Usually in a circuit, it's a very long wire that's connecting something to somewhere else, and you'll have different appliances or things in the circuit that require resistance or have resistance keeping the electrons from traveling through. So you could have more than one resistance, okay? So like let's say I have 3 resistors on here, okay? So there are your 3 resistors. And then that's what you're going to see for circuits for today. Okay, you're going to see some drawing like this. So you got a closed circuit, you got resistors, and you got a battery of some sort. Yeah? And we're going to use those formulas over here to calculate different things. Now, since we're doing a series circuit today, like let's say there's 3 resistors. Okay, well, electrons travel through the battery, well, out of the battery and through the wire, and they're going to travel all the way around the circuit until they reach back to the other terminal, right? So, these electrons that come out of here, they have to travel through each one of these resistors, right? So, in order to calculate the total amount of resistance that the electrons go through, you would just add up these resistors just like you would add up any numbers. Okay, so like let's say this one has 3 ohms of resistance, this one has 2 ohms of resistance, and let's say this one has 1 ohm of resistance. Okay, so let's say I ask, what's the total resistance of the circuit? Okay, so this is going to be a really easy question. What's the total resistance? Well, we're in a series circuit, okay? Series circuit just means that the electron has to travel through all of the resistors, okay? And you could think of these resistors as like flashlights, bulbs or something. Yeah, a bulb. So like when they travel through, it lights up. Yeah. So if you wanted to find out how much resistance all the electrons are going to go through, it would just be 3 plus 2 plus 1. So it's going to be 6 ohms of resistance is what they go through. Okay. And then you could ask, okay, so we know how much voltage comes out, right? How much energy all the electrons have. So you could then find out what's the total current in the circuit. Okay, so that's like 2 types of questions that I'm going to be asking. What's the total resistance in the circuit? What's the total current in the circuit? So if you want to figure out the total current, well, I know the total resistance, and I know the total voltage, so I can come over here to my formulas, and if I know voltage and resistance, I can figure out current, which current is I, right? So I can use my formula V equals IR. Now I am looking for current, which is I, so I'm going to divide by R. That'll cancel it from this side, and I have current is equal to V over R. And the voltage in my circuit was 12 volts, divided by the resistance of my circuit, which was 6. And I can say the current traveling through this circuit is 2 amps. So what's coming out of here is 2 amps of electrons. And remember, every amp is a ton and ton of electrons. Okay, so there's 2 amps of electrons traveling through this circuit and going through these 3 resistors. Yeah? Now, after you calculate that, I might start asking certain things about each resistor. Okay? Because now think about this as like I was saying, humans. Okay? So like let's say I have some mildly energetic humans, and there's 2 of them. Yeah? As they go through these resistors, each one of these resistors is like, I think of them as like a lake or something you got to travel. It's an obstacle, okay? So each one of these things is going to take energy to go through, yeah? So you're going to have to go through all 3 obstacles, and at the end, I want you to have used up all your energy, okay? I want you to be dead tired, and the battery can recharge you, and then you can run the obstacle again. So what we're going to do is this obstacle is obviously going to require more of the energy than either one of the other obstacles. So like let's say I say how much voltage is used here. Well, if you want to find voltage here, voltage is the formula V equals IR, right? So V equals IR. Well, I know how much current traveled through here. There was 2 amps. If you're thinking of them like humans, there was two humans traveling through here. And the resistance that they were having to deal with was 3 ohms, right? So how much voltage was used? Well, 2 times 3 is 6 volts. So here, at this one resistor, they used up 6 volts of energy. Now, like, let's say I come over here and I calculate the same thing. So I say, how much voltage is used here? So that's going to be I times R, right? Well, how much current was there? Well, there's still 2 humans, yeah? They didn't disappear after this obstacle. One of them didn't die trying to go through. They're all going to make it through the obstacle. So there's still 2 of them. Well, how much resistance does this obstacle have? 2 ohms. Okay, 2 times 2 is 4. So the voltage used up here was 4 volts. Okay, so now let's ask the same question over here. How much voltage was used here? Well, it's I times R, right? Well, there's still two humans. There's still 2 amps. And the resistance is 1. There's just 1 ohm of resistance. So 2 times 1 is 2 volts. So here, 2 volts of my energy was used. And now I can go back to the battery and be done. I'm done with it. Well, let's see how much this adds up to. 6 plus 4 is 10 plus 2 is 12. That's what's always going to happen on these. These circuits are so cool. Okay, so what happens is it's like these electrons can look through the wire and tell how much resistance there is, and they can go, okay, boys, we're going to use it all up. Okay? And they just go through the circuit, they use up all their energy, and they know when to use how much energy. Okay? So that's what you're gonna be doing on this worksheet, okay? Is figuring out now I'm gonna kind of go through that step process that we had here. I'm gonna give you some circuit, okay? On that circuit, you're gonna have resistors and a battery. I'm gonna ask you to find the total resistance, which we represent by big R, tiny t, sub t. So that, in my case here, our total resistance was 6 ohms. And then I'm going to ask you to find the total current after that. And so you might put an I with a sub t. My total current here was 2 amps. Then after you know the totals for all of these, like we have the total voltage, which was 12 volts. And then when you have the total resistance, which in this case was 6 ohms. And then you have the total current, which in this case was 2 amps. Then after you have all the totals, that does not look like a 2. After you have all the totals, you can start focusing on each one of the resistors. And I'm going to make sure that I ask it in that order. Okay, I'm going to lead you through so you don't get confused on these, because a lot of people get so confused on circuits. So we're going to keep them very easy. We're going to go step by step, and I'm going to make them easy. Okay? So just go through that. If you have any questions, ask me. Talk to you later.